Today I will introduce AC60 axis group control function. Let's start our today's training. First, let's have a view about the define of the axis group. Generally speaking, axis group is one of the important function of motion control. It allows us to coordinate the control of multi-independent single axis and to finish with some complex motion. And here in our software, here have 25 built-in axis group. And for axis group control, here we need to we have this almost in all function block we have these coordinate systems, and here is three most widely used coordinate system: PCS, MCS, and ACS. PCS means products coordinate system. This system is based on the workpiece, like this picture. Means the XYZ three direction is depend on the workpiece. Here we need to use some function block to set this workpiece. And for MCS is machine coordinate system. This is based on the robot zero origin position. Here in this part you can see these robots. The machine coordinate system of this robot is this one. XYZ is based on machine itself. And for ACS means axis coordinate system. For this system, the movement is based on each single axis. For example, if I set the target position as 1, 1, 1, and in MCS system, the target position will move to this position, 1, 1, 1. But if we are using ACS, 1, 1, 1 may means all axes rotate one circle. And here, when we select different coordinate systems and set the target position, the PLC will process this location and to control each single axis to do the interpolation. Some group motion state. After we power on and enable the group will change to this group standby states. And if you are using some function block, for example, MC group joke, it will change to group moving status. And if the group have any error, it will change to this group arrow stop. And you can use, for example, MC group reset to make it is a state back to group standby. This is one of the built-in axis group. This robot have 4 axes, 1, 2, 3, and here this part can rotate. So this is axis 4. And in configured page, you can see the machine code structure and some introduce about this model, about these robots, how to define the MCS and how to define TCS. And also we need to fill in machine code parameter according to our real machine. It will show you how to input the parameter. Here D1 is this part from the bottom to the first rotating axis. This the center position of this uh, servo motor and some other parameter. And also we need to we need to map the driver axis to this A1, A2, A3, A4, this to this model, and select the task to run this axis group motion control. Uh, Today I will use this model. This part is same as before. We can here right click application, add object, and select this axis group. And after add this axis group, we double click the axis group, and you will the software will ask you to select the uh, robot model. And here I select this one, rotary axis group. It's something like Delta robot. And also here I created three virtual axes to simulate this A0, A1, and A2. This is the uh, real device of this model. Something like this. It's usually this is used to uh, catch and put uh, the product maybe from the transform belt or something else. And here in this port, sometimes we will put some another uh, put some tool here to catch the product. And on the left side here have the defined of the MCS machine coordinate systems. It says when all these three axes and uh, and the same level, and this is the zero position of the machine of our tool. And here this is our zero position. So it means if you want to from zero position, if we set the target position as, for example, 0, 0, 0, 1, then all these three arms will go up to move this point to move this point go up. If our target position is 0, 0, and 1, for example, in the in this MCS. But if you set the coordinate system as ACS, and you want to go to this position, it means A2. This axis will rotate one road, but the other two axes will keep N0. Here we can you can Mhm. You can move your mouse to drop this axis to here, or select it in IO configuration global. And also we need to fill in the machine code parameter. For example, for this model, uh, uh, different also here also have picture to show you how to measure and measure the length of the machine. And here have no uh, and then the unit of all these parameter is uh, no limit, but you need to set all of them as the same unit. Here uh, I think I use as the unit of this all these lengths. Okay, and now let's have a view of some relative function block. First is this group power and group enable. For group power is used to add the axis to the axis group. So after run this function block, we can see we can say that all these three axes are in the same group. And then we need to use this MC group enable to enable all axes in the group. And also you can use MC power to enable all axes with three MC power function block because here we have three axes in this group. And group reach actual velocity and group reach actual position. Uh, yes, here we need to select the code system to get the reading position of the group axis group. And here I use the down flag of this MC group enable function block as the enable signal of these two function block. For the output velocity and position, we can use this compass and selector to get the position like this. During the program running, we can get the position here because it is a three-axis system. So here I only put three position here, X, Y, Z. And some other function block, for example, groups reset, used to clean the error and change the group state from group error stop to group standby. And the group set position used to set the position of the group according to the code system. And also here you can put one compressor to this position and set the target position one by one. Okay, and now I will introduce some motion control function block. First one is this group job 2, because in the software it says group job is not take effect anymore. So and then the software recommends to use this group job 2 to instead of. And for this function block, here backward and forward is used to jog our system. If we set ACS, it means here list forward and backward. List two is not bool type. It's area type, and each area have 6 member. Uh, because because in here we have max 6 axes in one group. For this system, we only need to set first three. For this system, we only need to set first three. Forward 0, forward 1, forward 2, and backward 0, 1, 2 for the 3 axis movement. And for ACS, it means the control is based on the axis, and MCS is based on the whole system. I will show it later. And the other 4 parameter, velocity, acceleration, deceleration, and drag is not the target motion parameter. It's the motion limiting parameter. And how to set the target velocity? We use these 4 parameters: V error factor and acceleration factor, torque factor, and the drag factor. We set the factor, and the real parameter will relative to the axis parameters. For example, here if you set the V error factor as 1, then your target velocity is 30, and your target acceleration is 100 if you set all factor as 1. So when you set this parameter, remember to check this here. Otherwise the machine may run too fast. Here, after power and enable axis group, we first try this ACS job and backward control for each axis. Here, when I change the chord system to MCS, you will see the reading position will change to this MCS. Okay. And the next function block is move linear. Here, sorry, I didn't change this picture. Here in my project, I use move linear absolute, and we have absolute and relative two function block. This is used to move to do the linear movement of our group axis according to the setting coordinate system. Position is our target absolute position, and it is also a area data type. And list 4 is not the limit parameter. List 4 is our target motion control parameter. And the factor is then here. Sorry. Oh, here we have this parameter. This parameter is default is first one, grid circle. It means, for example, when we move from position A, location A to location B, if we select the first mode, the movement will be the shortest path from A to B. So this is the fast way to go from our current position to target position. But for second, if we select it as axis, the motion will be controlled by each single axis. It means we will also achieve B from A to B, but it may be like this or like this. So it's not the shortest path. And for details, you can check here. We can in software. In software, uh, you can double click the function block, and here we have the very details introduction about each input and output parameter, and like this. Have all function block have a built-in document to introduce how this function block works, how to set the input and the output uh, parameter. Okay, and also here for this function block, we first use MCS code system and go to 0, 0, -5 position. Now, because now I'm using MCS, so the target position and the current position, you can see it's also 0, 0, 5, -5. But here, if I change it to ACS, you will see all three axes are changed to -0.864 because in this model, you can easily see because my target position is 0, 0, -5. So this part will go down because the negative direction of Z is go down. And you will see for this part go down, what will all these three axes will also rotate in this direction to go down. And the movement distance of these all three axes will be same. So that's why here. So that's why here when we change the change this to ACS, the three position of X, Y, Z, A0, A1, and A2 will change to same value. And usually we use MCS to for our robots. If we want to control this robot to catch and push something, we can first, for example, we can first jog the robot to this position, for example, and record the position and targets. For example, we need to move something from here to here. We can first drop to position 1 and record the position. And maybe here we need to go to here, another position, like this. Go to here and catch, and go to here, and then go to here. Put the product and go back. So we can first check what's these two position. For example, maybe here have something here. So we can't directly go from A to B. We need to go to the third point. And and also in here for the move circular move, we also have absolute mode and relative mode. The difference is the target position is based on zero position or based on current position. And some parameter, circle mode and aux position and the end position. First one is used to define how to decrypt our movement. Second, this parameter, this point is used to work together with this circle mode. End position is our target position, and the path truth is used to select the direction of the circle. For example, clockwise or counterclockwise, and the other parameter. Here, for this circle mode, we have three modes. First one is border. What border means? In this mode, our curve is composed of starting position and the border position. Here, border position is our aux position, aux point, and then the end point. So with 3 points, we can ensure one. I can how to say? We can get one curve, circle curve. So in this mode, these path truths don't work because after we get these 3 points, the curve is also Euclid. But for this mode, we can't describe a complete circle because if our start position and the end position is same point, then there will uh, have not only one curve, one movement path, and also this 3 point can't be in a straight line. Otherwise, we can't get a circle. Second is center mode. In this mode, we use start position, end position, and center position to get to our curve. And the center position now it is and now our aux point is our center position. And now this parameter path truth will take effect. It will define the direction from this direction or this direction. And also in this mode, we can't describe half of an circle or a full circle. Because if you can see if these 3 points in the same line, we will also have different possible about the curve. And here, for example, this is start position, end position, and usually and normally our center position should be in this line and this line. But if you set your center maybe in this position, the system will map this center position to this line and use this as the center position to do the movement. If this arrow is too bigger than 1% of the radius, then the PLC will not give the command and it will report an error. For example, your center is here and the map to this line, and this arrow is too big, which is bigger than 1% of our radius. Then in this condition, the movement will stop. Only when you have only a little error, then it will map it to here and do the movement. Okay, and then the last mode is radius mode. In this mode, it's a little complex. In this mode, we use the ox position to determine the plane of the circle, the direction. For example, yes, like this. And the length of the vector and the ox position will determine the radius of the circle. For example, if our ox position is 1, 1, 1, then the radius of our circle will be this value. And how to understand the direction? You can see in this picture, or maybe uh, in this picture, circle mode. Here, maybe it will more clear to show. Uh, our axis position is used to define this direction, and our circle, and the plane of our circle will be like this. And also, for example, if our start position and end position are not on the plane which is specific by the axis position, like this. For example, this is our zero position, and our ox position may be 0, 0, 1 in this direction. And normally, these 2 points should be our start position and end position should be here, and here, and get this curve. But if these 2 position is not and the same plane, uh, like this, A and B, then the movement will be changed to this uh, spiral movement, like this. It means uh, yes, it will perform like this. And now let's take let's use this example to build the learning of the function block. For example, here our start position is 0, 0, 0, and the end position is 5, 5, 0. If we want to use center mode to draw this curve, here our center should be 2.5, 2.5, and 2.5. And in the software, here I've already set the position directly. End position. Sorry, this is center position. And our end position is 0, 5, 5. It's a little because here I can't because here we don't have some. We only have here we can only use this to simulate the movements, but it's only is used for gantry robot, and here they have no delta robots model to show the movement, so I can't show you with the movements of this robot. Some function block. So generally speaking, uh, what we do is first create the axis group, select the model according to your machine, and fill in this parameter, machine parameter, and then use the function block to control your robots with the correct code system.